Ever had that moment where your Python code starts to feel, well, messy, tangled? As it gets bigger, it gets harder to manage? Well, there's a good chance you're missing out on one of Python's biggest superpowers, object-oriented programming, or OOP. We're going to break it all down and show you how to write cleaner, smarter code that actually makes sense. Let's dive in.
So you might start out with something like this, right? A simple Python list to hold some related info. We've got a name, an age, a role, it's all in there. And look, for a quick script, this is totally fine. But what happens when your project isn't so quick and simple anymore?
And that's where the trouble starts. When you have hundreds of these lists floating around, how do you keep track of what's what? Is index 1 the age or the rank? What if you forget to add one of the items? It gets confusing fast. And that is the exact problem object-oriented programming was born to solve.
So, how do we fix this mess? We start by thinking in a new way. Instead of just having loose bits of data, OOP tells us to build our programs around objects, and these objects are all created from a master blueprint.
Think of it this way. A class is the architect's blueprint for a house. It defines the whole structure, where the walls go, how many bedrooms it has, but you can't actually live in a blueprint, right? An object, on the other hand, is the actual house you build from that blueprint. And the best part? You can use that one blueprint to build as many different houses as you want.
So, at its heart, a class is just a template. It's designed to bundle two things together. First, the data you want to store, which we call attributes, and second, the functions that can do things with that data, and we call those methods.
All right, let's make this real. We're going to use the classic example, a dog. To create this blueprint in Python, you just use the class keyword and give it a name. That's it. This is the simplest possible class you can write. That pass keyword, it's just a placeholder, basically telling Python, hey, I'll fill in the details in a minute.
Now for the cool part. To give our blueprint some starting properties, we use a special method called __dinit_. Think of this as the setup instructions. It runs automatically every single time we create a new dog. See that self thing? That's just how the object refers to itself. So self.name equals name is just saying, okay, take the name we were given and attach it to me, this specific dog.
So we've designed our blueprint. It's time for the fun part. Let's actually use it to build some real individual dogs, from blueprint to reality.
This process of creating an object has a fancy name, instantiation. But all it really means is that you call the class name like it's a function, and you pass in the arguments that __init method asked for. So here, we've created two totally separate dog objects. We've got Miles, who's 4, and Buddy, who's 9. Same blueprint, two completely different dogs.
And this brings up a really key point. Some attributes belong to every single dog we create, their species, for example. We call that a class attribute. But other things, like a name or an age, are unique to each specific dog, and those are instance attributes. So every dog is a canis familiaris, but only one of them is our good boy, Miles.
But look, data is only half the story. Objects aren't just bags of information. They can do things, and they do things using methods. A method is really just a function that lives inside a class. Here, our speak method can use the self keyword to get its own data. So when we call it, self.name grabs that specific dog's name and pops it right into the sentence. Pretty cool, right?
Okay, the fundamentals are down. Now we get to the really cool stuff. This is where OOP gives your code some serious superpowers, starting with one called inheritance.
Imagine we're coding a dog park. We've got our general dog class, which is great, but we all know that different breeds are, well, different. A bulldog isn't the same as a Jack Russell Terrier. So how do we handle that without just copying and pasting our code over and over again?
The answer is inheritance. It's brilliant. We start with our general parent class, which is dog. Then we create a more specific child class, like Jack Russell Terrier, and tell it that it inherits from dog. What does that mean? It means that child class automatically gets all the parent stuff, the name, the age, the ability to speak, all of it, for free. It is the ultimate form of code reuse. But what if a child needs to act a little differently? No problem. It can provide its own special version of a parent's method. We call this overriding. Here, our Jack Russell Terrier class defines its own speak method. It's almost the same as the original, but we've given it a default sound, arf, to make it a little more specific to that breed. And this leads us right to our second superpower, polymorphism.
It's a really fancy word, I know, but it boils down to this one beautiful idea. Same operation, different behavior.
Let's see it in action. Say we have a bulldog object, and maybe we overrode its speak method to default to woof. So when we call .speak, we get a sound that's perfect for a bulldog. Now watch this. We grab a completely different object, a dachshund, and we call the exact same method, .speak. But because the dachshund class has its own special version of that method, we get a totally different result. That's polymorphism. Same action, different outcomes. It makes your code incredibly flexible.
So we've gone from a messy list to a whole virtual dog park with blueprints, objects, and superpowers. Let's zoom out for a second and look at the big picture. Why is this such a game changer?
You know, when you put it all together, the benefits are just so clear. OOP lets you bundle related data and actions together into these neat little packages. It helps you model real-world things in a way that just makes sense. Inheritance means you're not writing the same code over and over. What it all comes down to is this: it turns chaos into clarity, making your programs way easier to build, fix, and grow over time.
In the end, object-oriented programming isn't just about a set of rules. It's a whole new way of thinking. It gives you the tools to build things that are sophisticated, organized, and powerful. So you've seen the blueprint. The only question left is, what are you going to build with it?